So moving on to the next one, we have electric dipole. So what is an electric dipole? So magnet has two poles, earth has two poles. So 2 means what? Or di means what? Di means 2, right? Similarly, how does this electric field or how does this electric lines of force or electric charges have two poles? Whether they are north and south pole? No, right? So now what is an electric dipole? So electric dipole is nothing but it is the pair of two equal and opposite charges which are separated by a certain distance. Clear? That is, for example, if this is plus Q, then this will be minus Q. If this is plus A, this will be minus A. Okay, and it has the same charge, that is same magnitude it has. Magnitude in the sense, if it is minus 5 coulomb and this will be plus 5 coulomb. Okay, if this is 10, then this will be minus 10. So what is happening? The magnitude will be the same, but the charges will be opposite. Clear? So that type of arrangement or such type of charges, we call it as an electric dipole. So what is an electric dipole? The electric dipole consists of a pair of two equal and opposite charges which are separated by a certain distance. So that distance, we call it as a dipole length. So here you can see the diagram where I have just given a minus Q charge in this negative direction and this is plus Q. So both have the same magnitude, that is the magnitude will be the same magnitude, okay, but the distance is 2a. Okay, so the distance will be what? This is the dipole length, we call a small distance, okay, dipole length, which will be 2a. 2a in the sense, how it will be like, if you just have the middle point here, okay, if you have a middle point here, then what happens is, you will be having here A and here A, okay. So A and A consists of 2A, that is a dipole. Clear? What is a dipole? A dipole is nothing but it is the pair which consists of 2 point charges, that is which are equal and opposite charges separated by a small distance. So we have at the point, I'll take this point as A and this point as B. At the point A, I have minus Q charge and at the point B, I have a positive charge. So which are separated by a certain distance 2A. Okay, so this charges have the same magnitude, and next one is this has, or this is called as dipole length. Clear? So this is about an electric dipole. So what is an electric dipole? A pair of two equal and opposite charges separated by a certain distance. We call it as an electric dipole. For example, the magnitude in the sense, if it is minus 5 coulomb, this will be plus 5 coulomb. If this is minus 10 coulomb, then this will be plus 10 coulomb. So magnitude of these both will be the same. Clear? So that is how we define an electric dipole. Very easy to remember, because if you remember the picture here, then you can remember the definition. The definition is nothing but the pair of two equal and opposite. So it has they are equal, that is Q and Q are equal, and two equal and opposite charges, right? That is minus Q and plus Q, which are separated by a certain distance, which is 2a. Okay, so certain distance is there. That distance we call it as a dipole length. And another thing you have to remember here is, if I take a point at the center here, then from minus Q to this point O I'll take. Okay, so from A to O will be A, and from O to B it will be A. So A plus A is 2A. That is what we call it as a dipole length. Any doubts in this? If there are any doubts, please let us know so that we can solve it as soon as possible. Okay, and next, moving on to the next one, we have electric dipole moment. So I think you people have heard about momentum, right? Linear momentum or linear moment. Similarly, here also we come across a factor which is called as electric dipole moment. So what is this electric dipole moment? It is nothing but it is a vector quantity. First thing. So it is a vector quantity, and it is nothing but it gives the product between, or it is the product between the magnitude of either of charges. Okay, for example, when I take the diagram of dipole. So here I have plus Q, and here if I have minus, here if I have minus Q, then what is happening? This is an electric dipole because it has same charges and the length will be 2a, right? So as the length is 2a, these are having two equal and opposite charges, plus Q and minus Q. So as this has plus Q and minus Q, which is separated by a distance 2a, then the magnitude of one charge into the dipole length is given by electric dipole moment, and it is denoted by P. Clear? So what is electric dipole moment? It is nothing but it is the product of either of the magnitude of charges, because the magnitude is the same here. So either of the magnitude of the charges and the dipole length, which is 2a. Okay. So how can I write it mathematically? It is nothing but P is equal to, or P vector is equal to, what do I have? Q, which is the magnitude of the charge, and that is into 2L or 2A, okay, whichever you use. So till now I have used A, I will be using it as 2A. So this is nothing but we call it as electric dipole moment. So what is electric dipole moment? It is nothing but it is the product of the magnitude of the charge and the dipole length. Simple words. If you remember the equation, you will remember the definition. And what can you say the SI unit of this? Because see, Q means what? We have Coulomb. Okay. And what about this? We have length, which is meters. So what happens? The SI unit is Coulomb meter. Right? So the SI unit will be Coulomb meter. So coming to the first thing, we have electric dipole moment. It is a vector quantity whose magnitude is equal to the product of the magnitude of either charge and the distance between them. So the product from here, the product of the magnitude of either charge and the length and the distance between them. So its direction is from negative to positive. This you have to remember, because electric lines of force are always from positive to negative. But when I come across electric dipole moment, the whatever dipole moment is there, it is from negative charge to the positive charge. And another thing you have to remember in electric dipole, not electric dipole moment, electric dipole, that, okay, I will just show you that. So another thing what you have to remember in electric dipole is the charge in this, the charge in this dipole will be 0. Okay, so sorry, okay, it will be 0. Why it will be 0? Because we have the charges are of same magnitude. Okay, so what happens? The whatever charges are there, they are getting nullified. So if they are getting nullified, then obviously the whatever charge on that body or on that electric dipole, it will be 0. Okay, in an electric dipole. But when I consider an electric dipole moment, so when I consider an electric dipole moment, then the whatever the electric dipole moment direction is there, that is from a negative charge to a positive charge. Okay, that is from a negative charge to a positive charge along the line joining the charges. So this is nothing about the, this is like electric dipole moment, which is given by P. So now we have studied electric flux, we have studied electric field intensity, and we have studied electric dipole, and also we have studied electric dipole moment. So actually, why are we studying all this? Why are we studying all this is because we have to know how the charge behaves when it is on a certain line. Okay, whether it is on the surface or whether it is perpendicular, I have to know at a certain point how does the charge intensity, that is electric intensity, behave on that point. Okay, when the charges are there or when the dipole is there. Clear? For that we have, we are preparing. Before cooking, how we prepare all the ingredients, like how we keep all the ingredients into account. Similarly, what we are doing here is, we are taking all the definitions, all the knowledge, whatever we need, and then we'll be going it and applying on certain derivation, where it will be very interesting to find out how the point behaves, or what will be the electric intensity or the strength on a point which is unknown from the electric charge. Clear? So this is about electric dipole moment now. Next, moving on to the next, we have an important topic, and that is nothing but the field of an electric dipole. So I said you, first thing, electric lines of force move from positive to negative, but electric dipole movement has, that is, it comes from negative to positive, right? Similarly, what is an electric field or the field of an electric dipole look like, or what is it actually? What does it look like? We know, and what is it actually? We know, but how is it consisting? How will be the electric dipole field building up? Clear, that we'll know. The electric field for the pair of charges plus q and minus q at any point in space can be found using Coulombs law. So Coulombs law gives me the distance between, that is the force between two charges. Similarly, pair of charges, force, and also the electric field can be known using Coulombs law. And also the superposition principle, which we used in the multiple charges system, okay, system of multiple charges. And second one is the electric field E at a point P is obtained by adding electric field intensity at the first position, and that is E2 due to the charge minus Q. So when do you find out the electric field E, that is the total electric field or the total strength? When will you find out? When it is, that is, you have this E1, okay, that is E1 vector or the first vector on the charge Q1 and E2 vector on the charge Q2. So by the parallelogram law of vector addition again. So you have the parallelogram law of vector addition, which you had studied in first year motion in a plane chapter. Okay. So next, the results are simple when the point P is on the dipole axis. So you have to remember what is the dipole axis and also what is the equatorial line. If you don't remember also, I will be letting you know what is a axial line. Okay. So for example, what I'll do is, so now the goal of having all these ingredients with me, that is, why did I study this, why did I study this, why did I study this? So for this whole thing, there is an end, and that end is we'll be deriving a point, okay, where we have to find out the electric field on that point or the strength of the electric field on that point, which is near the dipole. So that dipole is in the two cases you can find out, right? So whenever I take a dipole here, what happens? So whenever I take a dipole here, if it is positive and this is negative, negative, right? So when I take this as negative, then what happens? First thing, the distance is 2a. Okay, so as the distance is 2a, this line, okay, in two cases only you can find out how. One is axial line, that is, axial means when the electric lines of force or when the dipole is, or when the electric lines of force are moving from positive to negative through the axis, okay, or when the lines of force or when the lines are moving from positive to, from or through positive and negative charges, okay, that I call it as an axial line. So here plus minus I have, here I have a point P, okay. Now I have to find out the electric field intensity at point P. What will be the strength of this charge or the charge near point P by this dipole? I have to find out. Clear? So this is my first goal. And the second goal is, now I have a parallel, like on the axial line is we have, now electric dipole, again I have an electric dipole I take, okay. So this is distance is 2a again. Now another point I'll take, which is here, okay, so which is perpendicular to the dipole, either parallel or either perpendicular. So after that only we can know, like if there are any angles we can just find it out. So either of two charges. So when I take it to the perpendicular, okay, so that time I have this triangle, and from this we will deduce the point P, how is it getting influenced by the dipole which is there nearer to it.